Welcome back to the deep dive. Today we're calling this one Robots Rising: Strategy, Space, and the Humanoid Horizon.
Sounds about right. It was certainly a packed week in the world of robotics.
Absolutely. We're jumping into another fascinating week of news and advancements. And this time, yeah, we're tackling robotics head on. We've got a great set of material here, including the sources you shared with us, plus a really thorough compilation from our research team.
They've focused it right down to the week of June 1st to June 8th, 2025.
Exactly. And it really shows just how dynamic this field is, doesn't it?
Completely. The findings take us, from these huge national strategies that could reshape global tech.
All the way to like cutting edge hardware.
Yep, incredible new hardware, the whole burgeoning field of humanoids, which is just exploding right now, robots even reaching out into space.
Wow.
Fascinating research coming out of labs, and of course, the ongoing complex journey of autonomous vehicles.
It's a lot to cover. So our mission, as always, is to sort of unpack the most important nuggets, the key insights from all this. Think of it as your shortcut, really, to getting up to speed on the progress and the challenges in robotics today.
Okay, so where should we kick things off? Maybe with something that has really major strategic implications.
Sounds good. What have you got?
Well, around June 8th, there was significant news about China unveiling something called Intewell. It's described in the material as a national-level AI operating system, specifically for robots.
A national level OS for robots. Okay, that sounds like a big deal.
Mm.
What makes Intewell more than just, another piece of software?
Well, the key thing that jumps out is the strategic angle. It's being framed very much as a major move towards technological self-reliance, especially within China's robotics industry, which is expanding incredibly fast.
Right. So less about the tech itself, maybe, and more about the geopolitics.
Exactly. It looks like a deliberate geopolitical maneuver aimed squarely at reducing dependence on foreign technology, particularly given, the current global tech tensions.
That context is crucial. So, okay, what are some of the interesting technical details? What does Intewell actually do?
Well, one aspect highlighted is this unified architecture. The idea is to integrate everything, like from the chip-level hardware right up to the software applications.
And the point of that is?
Streamlining, mostly. Streamlining processing, potentially cutting costs, lowering power consumption, basically getting more performance by having everything work together more tightly. Maybe even putting motion control and AI processing onto a single chip eventually.
Okay. And I saw something about a microkernel design.
Yes, that's right. Reportedly fewer than 10,000 lines of kernel code, which, they claim, makes it easier to verify, for security and reliability.
Makes sense. Easier to check if it's smaller.
And it's modular, too, designed to be adaptable for lots of different uses: smart manufacturing, energy systems, different kinds of robots, including humanoids.
The virtualization capability caught my eye, too. That seems important.
Very important. It uses a hypervisor, which lets it run multiple operating systems at the same time on one platform. The material mentions support for up to, 20 real-time OS instances?
Wow, 20.
Yeah, plus 3 non-real-time ones, and that includes compatibility with Windows and Linux. That's vital for robots doing complex tasks where timing is critical.
And the chip strategy is prioritizing Chinese chips, but still works with international ones.
That seems to be a really key strategic choice.
Yeah.
Yes, prioritize domestic makers like Huawei, Lungxin, Haigan that pushes the self-sufficiency goal, but keeping compatibility with NVIDIA, Intel, Qualcomm, ARM, Bi86, RISC-V.
So that allows broader adoption now, right?
Yeah.
In the transition. And lets them integrate into existing setups.
Exactly. It's a pragmatic approach to a long-term strategic goal.
And Kylan Technologies chairman laid out a pretty clear vision, didn't he? Build China's robotics on their own tech, reduce foreign dependence, aim for leadership, and, interestingly, unify their humanoid AI efforts under this one umbrella.
That's the stated goal. And if you think about the potential impact, providing this common, potentially optimized platform could really accelerate innovation inside China.
Yeah, lower the barriers for Chinese companies to develop new robots.
Precisely. And foster this tightly integrated local ecosystem.
Which, down the line, could mean more cost-competitive Chinese robots hitting the global market. A challenge to the established players.
That seems to be the clear implication, yes. The source material explicitly contrasted Intewell with open-source frameworks like ROS, Robot Operating System, and ROS2.
How do they compare?
Well, it's not just the technical approach, Intewell being proprietary, deeply integrated versus ROS being open source middleware. It's the fundamental goal. ROS is about providing a flexible framework, encouraging global collaboration and reuse. Intewell is positioned explicitly as a tool for national strategic advantage and technological sovereignty.
That really drives home that concept of techno-nationalism the material mentioned. Intewell seems like a textbook example.
It really does. And this kind of strong push for national control over core technologies, well, it could push other countries or blocks the US, the EU, maybe India to speed up their own sovereign OS or platform initiatives for robotics.
Which could lead to, what? A more fragmented global market. Systems not talking to each other easily.
That's a definite risk. More fragmentation, making interoperability harder between robots built in different regions.
And I guess this ties into all the increased international scrutiny we're seeing around data security, potential surveillance, IP protection.
Absolutely. It fuels efforts like the trusted robotics frameworks emerging in some Western countries. Those focus on verifiable security, ethical AI principles, transparent data handling.
It's fascinating. Something like an operating system, which most people think of as just code, is actually a key battleground in global tech competition.
It really is. And for you listening, this push for national control could eventually affect everything from, say, the supply chains for robot parts to the features and even the cost of the robots we might use in the future.
Okay, let's pivot a bit. From strategic software to, well, actual physical hardware. The material also covered some pretty incredible new tech. That Kim ultralight hand, for example, unveiled around June 8th, weighs less than a kilogram. That's tiny for a capable robotic hand.
It is remarkable, yeah. Huge implications for prosthetics, obviously, but also for humanoid robots. A key innovation mentioned is this linkage wire hybrid actuation system.
Hybrid? How does that work?
It tries to get the best of both worlds. It combines the strength and precision you can get from a 4-bar linkage mechanism with the flexibility and shape adaptability of wire-driven systems, so it can conform to objects better.
Okay, and there was something about the thumb being under-actuated.
Right, a clever bit of engineering. It uses something called a Geneva mechanism. Basically, it allows the thumb to move in 2 different ways, 2 degrees of freedom, but using only one motor, one actuator.
Ah, so that saves weight and complexity compared to needing multiple motors just for the thumb.
Exactly. Conventional designs often need several, so you get enhanced precision, good grip power, adaptability, but with significantly less weight and fewer parts.
So beyond prosthetics, which is obviously huge, why does this matter for other robots?
Well, think about current industrial robots or service robots. Manipulators, grippers, they're often a limiting factor. This kind of tech, better dexterity, maybe lower computational needs for grasping, could make collaborative robots, cobots, much more capable and safer for tasks needing fine motor skills. Manufacturing, healthcare, complex assembly.
So it pushes the whole field forward.
Yeah.
It puts pressure on existing gripper makers too, I imagine.
Definitely. It raises the bar.
Okay, moving from hands to mobility. Peer Robotics launched their Peer 3000 AMR autonomous mobile robot on June 6th. What's their angle with this one?
The core focus, according to the information we have, is tackling the adoption barriers for automation, specifically for small and medium manufacturers, SMM.
Ah, the smaller guys who often find automation too expensive or complex.
Exactly. So how does the Peer 3000 address that? Well, first, compatibility. It's designed to work with existing stuff, standard industrial pallets, trolleys. It can handle payloads up to 3,000 pounds.
So no need to overhaul the whole warehouse layout.
Hopefully not. And it uses overhead cameras for navigation.
Yeah.
That avoids needing complex floor modifications or sticking LiDAR targets everywhere.
Okay. And I saw something about an intuitive training system, human-guided.
Yes, that sounds like a key differentiator for those SMMs without robotics experts on staff.
No.
It reportedly has a simple system where a worker can physically guide the robot, literally push or pull it through the path or task they want it to learn.
Like teach by showing.
Pretty much. Plus, it does its computing onboard using edge computing, so no need for complex external IT servers or constant cloud connections, again, lowering that barrier to entry.
That really does sound tailored to remove those common pain points for smaller businesses. Cost, complexity, disruption, adapting to their reality.
It could unlock a pretty significant, currently underserved market for AMRs in manufacturing and logistics if it delivers.
And it signals a broader trend, doesn't it? User-friendliness, no-code, or low-code training. That's becoming really important in the AMR space.
Absolutely. Ease of use is a major selling point now.
Okay, one more piece of hardware news from that week. The report on self-healing robot skin around June 7th. That sounds like science fiction.
It does have that feel, but the material describe a capability where this skin material can apparently heal itself, like instantly, without needing a human to fix it.
Instantly. Wow. What's the significance there?
Well, think about durability and maintenance. Robots get bumps, scratches, damage, especially in tough environments. That means downtime, repair costs.
Right. A self-healing skin could dramatically reduce that.
Exactly. Less downtime, lower lifetime repair costs, better resilience overall, especially for robots in demanding places like heavy industry, disaster zones, maybe even space.
It just makes the robots fundamentally tougher, more reliable.
Precisely. And it could open up design possibilities too. If you can have softer, more compliant robot exteriors that repair minor damage themselves.
That could make them safer to work around. Less risk of injury from bumping into a hard metal shell.
That's the potential benefit for human-robot collaboration, yeah. Safer interactions.
Okay, let's switch focus now to humanoids. This sector seems to be generating a lot of buzz and investment lately. That definitely came through in the material you shared.
It's absolutely a hot area right now. Lots of rapid development, lots of market excitement.
The inaugural Robot Olympiad on June 6th, featuring humanoids doing sprints, agility tests. What's the real significance of something like that? Is it just a show?
Well, it's partly show, sure, but competitions like this are actually pretty important drivers for innovation. They force teams to push the limits, demonstrate real capabilities.
Like a public benchmark?
Exactly, a benchmark for where the tech actually is. And crucially, it boosts public awareness and, maybe more importantly, investor interest. It signals a move towards more general purpose, agile humanoids that can handle dynamic movement, operate in less structured human-like environments, getting them out of the lab.
Speaking of investors, a very concrete sign of market maturity was the launch of that Crane Shares Co-eyed ETF on June 5th.
Yes, the material noted that as reportedly the first U.S. exchange-traded fund specifically focused on humanoid robots and embodied intelligence.
An ETF just for humanoids, how does that work? What are you actually investing in?
So it's designed to track an index, the Merkube Global Humanoid and Embodied Intelligence Index. This gives investors exposure not just to the companies building the final robots, but the whole supply chain, the whole ecosystem behind them.
So companies making the actuators, the sensors, the AI software, the manufacturing systems,
Yeah.
even the raw materials.
Exactly. The list of top holdings mentioned in the source gives you idea. Lannis Rare Earths, Amphenol for connectors, Melexis for sensors, NVIDIA for the AI brains, Jadil for manufacturing, Infineon for semiconductors, Rainbow Robotics. It shows the breadth.
That breadth is interesting. And this ETF launch lines up with some pretty wild market projections we're hearing.
Yeah, like NVIDIA's CEO reportedly calling humanoids likely the next multi-trillion-dollar industry.
And Morgan Stanley projecting, what, a $5 trillion market by 2050? Maybe 1 billion humanoid robots by then?
Those are huge numbers. And it's important to include the cautionary note mentioned about firms like Interact Analysis. They talk about a potential hype cycle.
Meaning the excitement might be outpacing the actual results right now.
Potentially. There's a need for the industry to deliver tangible ROI, prove the value proposition, to justify those massive projections.
That's fair. But still, the ETF itself is a strong signal. Financial markets see real long-term potential here, and it makes investing easier, which could fuel more R&D.
Absolutely. It provides capital and also puts more pressure on these companies to deliver. Now, looking at the broader market dynamics described, you see the big players really emerging. Tesla with Optimus, NVIDIA focusing on the AI foundation model with GR00T, Boston Dynamics pushing Atlas's capabilities.
Agility robotics with Digit, Rainbow Robotics in there, Unitree.
Right. And there's that trend you mentioned, companies trying to develop key components like actuators in-house.
Why is that?
Because the specs for humanoids are so demanding. Lightweight, compact, powerful, energy efficient, often standard off-the-shelf parts just don't cut it.
Makes sense. What's driving all this demand? Why now?
Several factors are cited. Healthcare needs, like caregiving, industrial automation, trying to fill labor shortages, supporting aging populations, tasks in manufacturing, services, warehousing.
And China seems poised to lead in the near term.
Yeah, the material suggests that, driven by strong government support, subsidies, incentives, maybe a regulatory environment that allows for faster deployment, but globally there are still major challenges.
We touched on some of the high cost, getting truly human-level dexterity. Battery life is a huge one. Safety, regulation, public acceptance.
Exactly. These are significant hurdles. It's why some people talk about needing an iPhone moment for humanoids. A point where the technology, the usability, the cost all converged perfectly to create a truly transformative, mass-market, general-purpose robot, something that breaks out of niche applications.
Do those sources suggest we're close to that?
Well, the convergence is happening. You've got advancing AI, like NVIDIA's GR00T platform for training them. You've got hardware improving, like that Kim Hand we talked about. And costs could fall if manufacturing scales up. So the big investments from major tech companies suggest they believe that moment is getting closer.
And connecting back to our first topic, there's that geopolitical angle again. China's government support versus efforts elsewhere.
Right. Who achieves humanoid supremacy first has big economic and strategic implications. It's another competitive front.
Before we move on, just a quick reminder to everyone listening, if you're finding this deep dive into robotics interesting, please do hit that like button, subscribe to the channel, and turn on notifications so you don't miss our future explorations. Your support really helps us keep digging into these topics.
Definitely appreciate it. Okay, so where were we? Yes, robots aren't just staying on Earth.
Right. Let's talk about space robotics and some of the pioneering research happening back in the labs.
Space is a huge growth area for robotics. It has to be, really.
The UK's Albatross project reports around late May, early June, successfully demonstrated robotic in-space assembly.
Yes, a key capability. They used dual-arm robots to build a scaled-down truss structure, the kind of thing you'd need for, say, huge solar power satellites in orbit.
Why is building it in space so important?
Because launching massive pre-built structures is really limited by the size of rocket fairings, and it's expensive. Building things robotically in orbit allows for much larger, more complex structures without direct human intervention, lowering cost and risk.
And this positions the UK well in that emerging field, ISAM, in space assembly and manufacturing.
It does, and it's a great example of taking terrestrial robotics know-how, like the UK Atomic Energy Authority's experience with remote handling for fusion reactors, and applying it to space challenges.
Cool. Then there was that NASA mission redirect on June 8th.
Right, shifting the focus for a major deep space exploration mission from Jupiter's moon Europa to Saturn's moon Enceladus.
Why the switch?
According to the material, it was driven partly by advances in robotic tech, but also a reassessment suggesting Enceladus might actually be a better bet for finding signs of life. Lower radiation was a key factor mentioned.
But they can still use the tech developed for Europa.
Exactly. They plan to leverage things like the specialized landing legs designed for icy surfaces, the advanced camera navigation systems, the IC-PIC subsurface sampler designed to drill down about almost 8 inches,
Wow.
and the sophisticated autonomous software needed to operate so far from Earth. It really shows how robot capabilities directly shape our biggest scientific goals, like the search for extraterrestrial life. Robust autonomy is absolutely essential out there with those communication delays.
And commercial space is playing a big role in the logistics now. That SpaceX Dragon return on June 8th brought back 6,700 pounds of advanced robots.
Yeah, from something called a wild space mission. Details were sparse, but the sheer weight of robotic cargo coming back suggests commercial spaceflight is becoming routine for transporting significant robotic systems to and from orbit. That points to maturing infrastructure and growing demand for space robotics overall.
Okay, back down to earth. Let's talk cutting-edge research. That summary from AI Frontiers, looking at 24 recent computer science robotics papers, mostly from RCIV in early June. That gave a great snapshot. What are the big themes?
Looking across that synthesis, several key themes kept popping up. One big one is simultaneous planning and learning robots, figuring out what to do and how to do it on the fly.
Not just following pre-programmed steps.
Right. Another huge one, efficient sim-to-real transfer. This is critical. How do you train a robot really well in a simulation, which is fast and safe, and make sure those learned skills actually work in the messy, unpredictable real world?
That seems like a fundamental challenge.
It is. Then there's a lot of work on robust and safe control methods essential if robots are working near people or in complex situations. Also, increased use of synthetic data for training AI models, breakthroughs in human-robot interaction, or HRI.
Making them easier to work with.
Exactly. Bio-inspired designs, borrowing ideas from nature, and continued refinement of the core AI techniques. Reinforcement learning, planning algorithms, model predictive control, or MPC.
The summary specifically highlighted a system called Fabrica.
Yeah, Fabrica was presented as a dual-arm system that showed really impressive generalization. It could apparently assemble objects it had never encountered before, with an 80% success rate in real-world tests. And it demonstrated successful sim-to-real transfer for these tricky manipulation tasks.
That generalization is key, isn't it?
Right.
Moving beyond robots that can only do one very specific thing perfectly.
It's crucial for getting robots out of rigid factory lines and into more dynamic environments, homes, construction sites, small workshops. The focus on better HRI and also human-in-the-loop learning is about making robots learn more intuitively from humans, making them usable by people who aren't robotics PhDs.
Were there other specific papers mentioned that illustrated these trends?
A few really stood out in the notes. Iron Cub 3, the jet-powered flying humanoid.
A flying humanoid. Seriously?
Nice. The research reported on initial controlled flight tests, pushing the boundaries of multimodal mobility, walking and flying, potential uses, maybe disaster response, inspecting complex structures.
That's definitely pushing boundaries. What else?
Gaussian fusion.
Yeah.
This was research focused on autonomous driving, using a specific mathematical technique, 2D Gaussian distributions, to fuse data from multiple sensors like cameras, LiDAR, radar more efficiently and interpretably. Part of that ongoing quest for super reliable AV perception.
Okay, making sense of all the sensor data better. And Homer.
Homer stood for learning mobile manipulation tasks in the wild, meaning in actual homes. It used imitation learning, watching humans, combined with other control techniques. Apparently achieved high success rates on complex home tasks like opening drawers or picking things up, using only a few demonstrations per task.
So getting closer to robots that could actually help out around the house?
It's a definite step in that direction, yeah. Moving beyond the lab into real, cluttered home environments. Overall, the research landscape shows this broad push towards robots that handle complexity, uncertainty, interact safely, and learn more easily. The fundamental work is really accelerating.
Okay, let's bring the focus back toward things we might encounter sooner on the roads. The autonomous vehicle landscape. Still a mix of progress and, well, problems.
Definitely. Progress, yes, but also significant hurdles, especially around deployment, regulation, and public trust.
There was that notable incident mentioned around June 6th, a Tesla robotaxi reportedly hitting a kid-sized dummy during a test.
Yeah, and while dummy tests are standard procedure for safety validation, incidents like that, especially involving scenarios with vulnerable road users like kids, inevitably grab headlines.
Fuels public concern, right?
Yeah.
Even if the overall stats show improvement.
It does. It raises public and regulatory questions about how well AVs perceive and react in complex edge case situations. It can damage public trust regardless of millions of miles driven safely elsewhere, and that creates a more risk-averse climate for regulators like NHTSA. It can definitely slow things down.
Speaking of regulators, there's legislative action in the U.S. The Autonomous Vehicle Acceleration Act of 2025, Senate Bill 1798, introduced back in May.
Right. This bill tries to tackle a core issue for getting Level 4 and Level 5 AVs, the ones that are truly driverless in certain conditions, or all conditions actually certified and deployed at scale.
How so? What's the problem it's trying to fix?
A big one is that current Federal Motor Vehicle Safety Standards, FMVSS, were written assuming a human driver. They have requirements about steering wheels, pedals, mirrors, position for a human. Things a fully autonomous vehicle might not need or have. That makes the certification process very tricky.
So the bill aims to give the Department of Transportation authority to create exemptions or amend those rules for driverless designs. Yeah. And develop a national roadmap.
Exactly. It acknowledges the regulations need updating for this new technology and tries to create a clearer pathway for the industry.
The material included context from groups like AVIA, the industry association, saying they've driven over 145 million autonomous miles, but the lack of a clear federal framework is holding back wider deployment.
And on the flip side, you have groups like OOUDA, representing truckers, raising serious concerns about safety, especially for commercial trucks, and of course, the potential impact on jobs. Plus, you still have debates happening at the state level about things like needing human remote operators.
It really highlights the central challenge for lawmakers, doesn't it? How do you balance encouraging innovation, keeping the U.S. competitive in AV tech, with ensuring public safety is absolutely paramount?
It's an incredibly difficult balancing act. Every incident, every stakeholder concern has to be weighed. The ultimate success of any legislation will hinge on finding that sweet spot between being robust on safety, but flexible enough for the tech to evolve.
And even with this federal push, the material suggests we might still end up with a patchwork of different state regulations.
That's a definite risk. Unless the federal law clearly harmonizes or preempts state rules, which is often legally and politically complicated, companies might still have to navigate different requirements in different states, which complicates national rollout strategies.
Let's talk broader impacts. The economic and societal potential cited is huge.
Oh, yeah. Reduced accidents is the big one often highlighted. increased productivity, lower transport costs, maybe optimized fuel use. Estimates mention run into hundreds of billions annually just in the US, potentially millions of new jobs in supporting industries.
But there's a flip side, the disruption.
Absolutely. Job displacement for professional drivers is a major societal concern. That requires serious thought about retraining programs, social safety nets. Governments also face potential hits to things like fuel tax revenue or parking fees if mobility shifts drastically.
What about infrastructure and the environment?
Potential benefits there, too. Optimized traffic flow, less congestion, especially if AVs lead to more shared mobility. Electric AVs could cut emissions. But there's also a warning.
What's the warning?
If AVs just make driving super easy and convenient for individuals and they aren't mostly shared or electric, we could actually see more vehicle miles traveled. That could worsen congestion and emissions.
So the benefits aren't automatic. They depend heavily on policy choices, like incentivizing shared and electric AVs.
That seems to be the crucial takeaway from the sources. Policy really matters in steering this towards positive outcomes, and proactive investment in helping the workforce adapt is seen as essential to avoid just exacerbating inequality. We'd love to hear your thoughts on this. How do you feel about the pace of AV development and regulation? Let us know down in the comments.
Wow. Okay, pulling all these different threads together from the material this week. It's been an absolutely massive period for robotics, covering so much ground.
It really has. You go from these high-level strategic moves with national operating systems
And huge market investments pouring into humanoid.
down to incredible tangible hardware like that ultralight hand or the self-healing skin.
Plus fundamental research pushing the limits of robot learning and how they interact with us.
And then you've got robots literally leaving the planet for space exploration, while AVs continue that complex dance with reality on our roads. It's quite the spectrum.
And the clear thread running through almost all of it is AI, isn't it? It's the engine driving these advancements.
Unquestionably. AI is underpinning the OS, the control systems, the navigation, the research breakthroughs, the autonomous decision-making, everything.
And the result is robots becoming more versatile, moving beyond those very structured factory settings into more complex places, our homes, outdoors, even space.
But as we've hit on throughout, these exciting steps forward come bundled with some pretty significant challenges.
Right, safety concerns like with the AV incident, ethical questions around AI bias, job displacement, data privacy, public trust is a big one.
Then there's the need for workforce transformation, addressing the skills gap. The security of these increasingly autonomous and interconnected systems is critical.
And policymakers are clearly struggling to keep pace. That regulatory lag, the lack of consistent global standards, it creates uncertainty and fragmentation.
These are all major hurdles that need active engagement alongside the tech development.
Absolutely. And for you, listening right now, remember, these aren't just niche tech stories. They're shaping the industries and technologies that will likely impact your work, your life, maybe even your investment portfolio in the years ahead.
And as we wrap up, there's a fascinating tension highlighted by the material you shared this week. On one side, you see the spirit of open, global scientific collaboration, especially in fundamental AI and robotics research. Findings shared on platforms like RFEV, researchers building on each other's work across borders.
But on the other side, you have this growing focus on national control, on strategic platforms like Intewell, a drive for technological sovereignty, for competitive advantage defined at the national level.
So maybe a final thought for you to ponder, drawn directly from these developments. How is this tension between global open innovation and national strategic competition ultimately going to shape the future of robotics?
Yeah, who gets to develop the technology? Where will it primarily be deployed? And maybe the biggest question, who ultimately benefits the most from these powerful advancements?
It's a fundamental question hanging over the field right now.
It certainly is. Well, thank you again for sharing all these fascinating sources with us for this deep dive. It's always illuminating to see what you're tracking.
My pleasure. It's always great to discuss this stuff. Looking forward to the next batch of material you uncover.
We'll see you on the next deep dive.